Yes, dear students, today we are going to discuss one of the important chapters. So that is units and measurements. Okay, so this is easy, and so to get the marks also, it's very easy, the chapter. So let us take. So even in 2026 also, two questions they gave, and so now, and all the dimension formula you have to remember, that all second year dimension formulae, so self-inductance and also this resistance, capacitance, magnetic field induction. So all the dimension formulae you have to remember, by that we can. So one example and one question we'll discuss. So let us take what distance traveled by a particle in the nth second is Sn is equal to u plus a by 2 into 2n minus 1, where u is the velocity and a is the acceleration. The equation is. So let us see, this is dimensionally so correct or not, and also we can say this is, and also we can say what is the dimensional formula for Sn. So dimension formula for Sn, in this Sn is equal to u plus a by 2 into 2n minus 1. One thing you have to remember, so this is what dimensionally correct. So as this physically correct means what dimensionally must be correct. Okay, that you have to remember, right? So dimensionally correct may not be physically correct. So let us take what theta is equals to. Let us see. Then L is equal to r theta. Then theta is equal to L by r. We can. So this is physically correct. Then what about dimensional? If you check L by L, so LL cancel. This is dimensionless, as the angle is also dimensionless. That's why dimensionally it is correct. Of course, physically is also correct. Suppose if any student wrote theta is equal to R by L as a wrong, this one, because L is equals to R by theta is wrong. But this is what physically L is equal to R by theta, which is wrong. But it is showing dimensionally. This is L, this is also L, as this is what dimensionless right side, even angle is also dimensionless, dimensionally correct. But physically, so this is what wrong. That means what dimensionally correct equation, we cannot say physically, so always correct is wrong. But you have to remember, so physically correct equation, dimensionally must be correct. Okay, so but dimensionally correct equation physically may or may not correct, because so theta is equal to L by R, it is showing what dimensionally correct. Even if I write what R by L also, it is also showing what dimensionally correct, but physically it is wrong. That's why dimensionally correct, physically may or may not correct, but physically correct equation, so dimensionally must be correct. Okay, these things you have to remember. And one more point you have to remember, that is theta is the angle. The physical quantity which has what unit but no dimension formula is the angle. The unit of angle is radians, but so dimensionally there is no dimension formula for angle, m0, l0, t0 we get. But so it is having what unit. The quantity which has unit but no dimension formula is, you can say, angle. Okay, so now look at here. This is what dimensionally correct or not. Dimensionally must be correct, because this is what physically correct. So physically correct means it should be dimensionally correct. But what is the dimensional formula for Sn? Now we take what is the dimensional formula for Sn. But actually by seeing this one, so but it shows Sn is equals to, I'll write here. So let us take, so this one, I write here, Sn is equal to u plus a by 2 into 2n minus 1. If you check this one, but it shows u is what, LT minus 2. This is LT minus 1 plus A is the acceleration. 2 is, of course, constant. This is LT minus 2, but this is what T. So it shows LT minus 1, LT minus 1. So then we can say, so as according to principle of homogeneity, this one, and even Sn is what, LT minus 1. So actually, so this one in the books are this they give Sn is what, LT minus 1. Because most of the students, they confuse Sn is what, LT minus 1, they say, which is wrong. Okay, so the dimension formula for Sn in Sn so is Sn is equal to u plus a by 2 into 2n minus 1. The dimensional so formula for Sn is LT minus 1 is wrong. Okay, but don't say this is what LT minus 1, even this is LT minus 2. Of course, this is T. So that's why this is according to principle of homogeneity. Right side is LT minus 1, LT minus 1. That's why left side is also LT minus 1. That's why the unit of Sn so is LT minus 1, but that is wrong because most of the students they confuse and they say the answer is LT minus 1. Even in the options also LT minus 1 will be there. But LT minus 1 is wrong, Sn. But what is the correct one? So actually, this is what simplified form of Sn, but actually the the original formula, actually we can get u into 1 plus a by 2 into 2n into 1 minus 1 square, we get like this. But actually what we are doing, when 2n into 1, 2n, 1 square is 1, so u into 1 is u. That's a simplified form. We are taking u plus a by 2 into 2n minus 1. By seeing this one, we are saying what Sn dimension formula is LT minus 1, which is wrong. But actually correct one is u is LT minus 1, but 1 is what it is a time at the second, so L, and this one is what LT minus 2, this is what LT minus 1 into T plus. So this is what LT minus 2. Of course, this is what no dimension formula, but this is what T into T, T square minus T square. Of course, according to principle of homogeneity, that is also T square. So this cancel, this L plus L. That's why this is also L. That's why what is the dimensional formula for Sn? In Sn is equal to u plus a by 2 into 2n minus 1 is L, but not LT minus 1. So this is wrong. LT minus 1 is wrong. So what about Sn? So this is LT minus 1 is wrong. But what is the dimensional formula for Sn? In Sn is equal to u plus a by 2 into 2n minus 1 is L is the correct answer. But so this one is what LT minus 1 is wrong. Okay. So this is what one important question. So must have to remember. Right. Now, and also we can say this is what? Physically correct, even dimensionally is also correct. Okay. So, right. So, you take this one. Right. Next, we just take now, let us come to the second question. According to principle of homogeneity, all terms should have same dimensional formula. Okay, now we come to this one. So let us take even one example I'll give. So let us take what S is equal to ut plus of at square. So it is what physically correct. So dimensionally must be correct. Then, so according to the principle of homogeneity, it contains what the terms 1, 2, 3, but all the terms should have what same dimension formula. So, but what about u? LT minus 1 into T plus this is no dimension, LT minus 2 T square, therefore L, and also this is L, therefore this is L. But according to principle of homogeneity, all should have same dimension formula. Okay, so then based on this one, now we come to this question. Let us take, and one more important I want to discuss, that is, so let us take, so exponential power and also trigonometric functions, logarithmic functions, exponential function should have what constant? That is what it's a constant related. As it is a numbers related, as it is what number dimensionally, so this one is what dimension should not be there. It is a constant. So let us come to this one, for example. So let us take what sine 30. So this sine contains what it is a 30 degrees only, there is a meaning, but 30 is a number. So, but whole thing is also a number. So that means what trigonometric function, sine, cos, are cos inverse and logarithmic function, exponential function, all. So this one is what related with the number. That's why this should have what? So dimensionless quantity. Even the whole thing is also having dimensionless. It's a dimensionless quantity. Okay. Now, even logarithm also, log 1, log 2, log 3. So logarithms contains what meaning? If it is, so contain with the numbers. Okay, log 2, log 3, log 4. Even the values also you get a number. That's why, so log of something. So is a number. This is a number, dimensionless. This one is also number. So it is a logarithm is associated with the number. That's why dimensionless. The whole thing is also a dimensionless quantity. So that's an exponential, this one is or sine inverse. Okay, sine inverse 1 by 2 is also this angle. This whole thing is what sine inverse associated with the number, and the whole thing is also a number. That's why it is dimensionless. Okay, right. Now we come to even exponential, e power, whatever this one is there. Okay, whatever this one is there, e power or e power minus exponential power, logarithmic function, trigonometric function, inverse trigonometric function. So associated with the numbers are dimensionless. The whole thing of that is also a dimensionless. It is also, so it's a number, that's why dimensionless. Based on that one, we can do this question. So let us take that question I am doing by changing the color. Let us take, yes. So x, this is what given as V naught by A, 1 minus e power at. Right. Then this is the position of the particle. Position means what? It is a distance, but exponential power. As it is an exponential power, exponent of power should have it's a number or associated with the dimensionless. This one, at is a dimensionless quantity. Dimensionless quantity, I can take it as what? Either 1, 2, 3, anything. It's a number. That's why a is equal to 1 by t, or a is equal to t power minus 1. Therefore, so dimensional formula for a is t power minus 1. Now, so this one is what? Number. This one is also according to principle of homogeneity. Wherever plus or minus is there between the two quantities, they should have. So this one is what? Same dimension formula. This is dimensionless. Even this is also dimensionless. The whole thing is the dimensionless. Therefore, x is equal to V naught by A, or V naught is equal to x into A, or V naught is equal to x is L, because it is the position. A, just now only we got the dimension formula, t power minus 1. That's why V naught is LT minus 1, A is t power minus 1. So A is LT minus 1 is asking about which one? So V naught and A. But what about V naught? V naught is LT minus 1, A is t power minus 1. Therefore, the fourth option is the correct one. Okay, so right. Right. Next one, next we go to another question. Let us take one question based on this one we take. Yes. Now let us take what this one based on the previous according to principle of homogeneity. Let us see. So this is what it is. So is the coefficient of viscosity A by B log Bx plus C is dimensionally true. Okay. Then C is the dimensionless quantity. B has dimensions of -1 in length. Dimension formula of A is, so like that is asking. Let us take, just now I said, either trigonometric function or inverse trigonometric function, logarithmic function, exponential function should have. So this one is what? Associated with a number or dimensionless. Or we can say whenever plus or minus is there, according to the principle of homogeneity, A plus or minus B is equal to C if it is given. According to the principle of homogeneity, so dimensional formula of A so is equal to dimensional formula of B should be equal to dimensional formula of C, we can say. Okay, so or we can write it as what? A by B plus or minus CD is equal to E. Even this also we can say. So dimension formula of A by B is equal to dimension formula of CD is equal to dimension formula of E. According to principle of homogeneity, all should have same dimension. Okay, according to this one, now we can say wherever plus or minus is there in between the two quantities, they should have same dimensional formula. Okay, so let us take what here. They should have what? Same dimension formula. And also we can say this logarithmic function. I'll change the color. So this logarithmic function so should have associated with logarithmic function associated with a number. That means what? It is a dimensionless. As it is what? Dimensionless. Then bx plus c is a dimensionless. Dimensionless means what? It's a number associated with the number. So once if it is the number, so then we can take it as what here. So according to the principle of homogeneity, dimension formula of this one is equal to dimension formula of this one is equal to dimension formula of that one. Or bx should be equal to 1. Therefore, b is equal to 1 by x, or b is equals to what we can write? L power minus 1. X is the distance is given. So what is the dimension formula for b? So this is what L power minus 1. But what is given? B has dimension of minus 1 in length. Yes. B has dimension of minus 1 in length. Yes. This is what second one is what correct. And also C is dimensionless. Now look at here. So according to the principle of homogeneity, Bx is equals to 1, or even C is also equals to 1. That means what? C is dimensionless. So C is what? Dimensionless quantity because it is a number. Okay, now the dimension formula for A. So now we can take it as what here. This one is, this whole thing is also a dimensionless. Changing the color, yes. This one is what? Whole thing is also dimensionless. As it is what? Dimensionless. Now we can take it as, so this one is eta is equal to A by B we have. Okay, then what we can take here, we got the A, this one is what? The B dimension formula, A is equal to eta into B. So now the B dimension formula is given. Now, so this is about coefficient of viscosity. So now coefficient of viscosity dimension formula you can calculate. So then this one is either you know, otherwise you can take it as what? Like this. So by taking what? F is equal to eta A into dV by dx. From this you can calculate. You need not to remember the dimension formula by using this one. F into dx by A dV. Even by using this also we can take, that is m1 L1 t minus 2 into L by, this is L square into, this is the velocity Lt minus 1. Okay, velocity gradient we call V by X. So this L square cancel. We have m1. So this is what? L minus 1 and also T minus 1 we have. This is the dimension formula for, so coefficient of viscosity. Okay, if you can remember, so actually we can remember this one, but otherwise need not remember, you can do from that. So m1 L minus 1 T minus 1 into L minus 1, then m L minus 2 T minus 1. Yes, even m L minus 2 T minus 1, even this is also correct. So 1, 2, 3 correct means what? All are true is correct answer. Okay, this is the way you can do this question. Right. Now, let us take another one. Even we can take similar question. We take this type of question. Let us see. Even we have is asking, let us take, then what about the equation of state? Yes, equation of state of some gases can be expressed this way. P is the pressure, V is the volume, theta is the absolute temperature, A and B are constant. The dimension formula of A is. What about the dimension formula of A? So you can say, let us take simply just now what I gave according to the principle of homogeneity. So there is what? Plus is there. If it is what? Plus is there between two quantities, okay, what happened? Those two quantities should have same dimension formula. That means P is equals to, let us take, change the color. So P is equals to A by V square. A is equal to, we can write it as what? PV square. Then we know what pressure dimension formula? M1 L minus 1 T minus 2, and V is the volume. L cube whole square means what? L power 6, M1 L power 5 T power minus 2. This is the dimension formula for A we can. Even, so we can take another one. So this is what? P plus A by V square, van der Waals equation, V minus B is equal to RT if it is given. What is the dimension formula for A by B? If they ask like this, same, according to the principle of homogeneity, what we can take? So these two should have same dimension formula. These two should have same dimension formula. Already we got dimension formula for A, we got m1 L power 5 t power minus 2. Then V minus B, in between the two quantities, plus or minus is there. So they are dimensionally correct. Therefore, B is equal to volume. So which is equal to L cube. This is L cube, then m1 L square t minus 2. That means A by B. So dimension formula is m1 L square t minus 2, or A by B dimension formula is equals to work done. Okay. So our energy, A by B, similar gives energy, or so this one work done, the dimension formula it gives, right? Yes. Right. Next one, let us see another one. Yes, even this also we can take. How do we get this one? So if epsilon naught is the permittivity of free space and E is the electric field, epsilon naught E square has the dimension. So in this one is capacitors, we have energy density. Energy density. So energy density of a capacitor, we can write half epsilon naught E square. So any of half is the constant, which is equal to energy density. What is the energy density? So this is equal to half epsilon naught E square, or epsilon naught E square is equal to 2 into energy density. Of course, 2 is the number. Then energy density is equals to, we can write it as, energy density is nothing but energy density. Energy density nothing but energy per unit volume. That is equal to, what is the energy? m1 L square t minus 2. Volume is L cube. Therefore, m1 L minus 1 t minus 2. This should be the answer for this one. So then m L minus 1 t minus 2, that is energy density. Don't write epsilon naught dimension formula. Don't write electric field intensity dimension formula. But just remember energy density. So formula you know, half epsilon naught E square. From that we can get energy density is energy per unit volume. Any energy density means what? Energy per unit volume, or velocity gradient, or pressure gradient, or temperature gradient. Whenever is given velocity gradient. Velocity gradient is nothing but, so difference in velocity by, so this is what velocity v1, v2. So then up to what length? This is what? From at a distance of L, the difference of the velocity is v1 to v2. Therefore, difference in velocity by, so the distance between them is L. So this is what velocity gradient. Always remember, gradient means what? It is per unit length. Therefore, now, so let us take what? Temperature gradient. We'll get in heat transfer we get. So in conduction, temperature difference divided by length, and also pressure gradient. Pressure gradient. Pressure gradient also pressure difference divided by length. This one is, so always you remember gradient. You have to take what? Per unit length. Okay? That you. Right. Next one. Now, let us take important, let us see, even, so let us take what in this. So very simple, this one we can take. This type of things also they are asking. Let us take, so how do we get density of the liquid is given. So then what is its magnitude in SI system? Very simple. So 0.625 gram per centimeter cube. This is in, actually it is in CGS. We have to convert into SI. Then, so what you have to do? 0.625, 1 gram. 1 gram is equals to how many kg? 1 kg is 1000 grams. So that's why 1 gram is equals to 1 by 1000 kg. And also 1 meter is equals to 100 centimeters, or 1 centimeter is equals to 1 by 100 meters whole cube. Okay, because the centimeter is 1 by 100. Yes, that is equals to 0.625 into 1 by 1000. This is kg by. So this is equal to 1 by 100 into 1 by 100 into 1 by 100 meter cube. That means kg per meter cube is this side. So now we can take it as what? 0.625 by 1000 into this hundreds comes to numerator 1, 2, 3. So this one is what? 1, 2, 3 we have, and we have what? 1000, which should be equal to 625. This is kg per meter cube, which is nothing but SI. Okay, that's all. Right. Next one. Now we come to, let us take. So then this type of things, let us see how do we get this one. Yes, even similar to this one. So we'll take one question. Let us see. Before, yes, even this also according to the principle of homogeneity we can say, right? Let us see. So the potential energy of a particle moving along direction varies. V is equal to ax square by root x plus b. So what you have to do here, V is equal to potential is equals to our potential energy. Okay, so this is about what? Potential energy. Okay, which is equal to ax square. Potential energy is nothing but energy. Ax square by root x plus b. What you have to do according to the principle of homogeneity? So what is asking here? A square by b is asking. What you have to do according to the principle of homogeneity? These two should have same dimensional formula, or b is equal to root x, or b is equal to L power 1 by 2. This is the dimension formula for b. Now, then what about this one? Potential energy is nothing but energy m1 L square T minus 2 A L square by. This whole thing is the same dimension formula as this one, that is equal to L power 1 by 2. Then now we have m1 L square T minus 2 into L power 1 by 2 by this is L square. Then A is equals to m1 L power 1 by 2 T power minus 2 we can. Then, so now we can take it as what? Then what about? So a square by b. A square by b is nothing but m square L to the power of 1 t power minus 4 by b is L power 1 by 2. Then if you take into numerator m power 2, L power 1 minus 1 by 2, which is equal to 1 by 2, and t power minus 4. That should be the answer. Yes, it's the third option. Right. Next one. Yes. So let us take, so this one, this is the way we can do in this. Now, another thing, let us take this one. So this is also one important thing you have to remember. Integral of dx by 2ax minus x square. Of course, this is what? Under root or whole power 1 by 2 to the a power n sine inverse x by a minus 1. Then what about the value of n is? Then what is the value of n? I already told, according to principle of homogeneity, trigonometric functions or inverse trigonometric functions are given. So trigonometric functions or inverse trigonometric functions, so this is associated with the numbers. That's why the whole thing is a number. Once if it is a number, so this is what? Dimensionless. Once if it is dimensionless, x by a, so this is what? Dimensionless, or we can write it as what? Simply. So because the plus or minus is there in between the two quantities, they should have same dimension formula. That means, so this is what? No dimension. This one is also no dimension. It's a number. That's why x is equal to what we can write? A we can write. This is what? X is equals to a, where x is the distance we can say. So let us take what? X is equals to a. Now, then we can take it as what? Dx. It is the difference of length or the distance. So what? Even this integral is not necessary while doing what? This dimensional analysis. Need not to remember the integration part or differentiation part. Need not to remember. Okay, right. So then not necessary the concept of integration or concept of differentiation is not necessary. So in physics, while taking this type of things, then what about this one? It is a difference. Difference in the distance means what? L. Okay, so need not to take what this integration, only it is the integral. So it is the sum that it's showing by. Then we can take it as what? 2 is the number, x and a. So this is what same as x and say, this is what same, or we can take it as what? Simply if it is what? X also we can say dx is nothing but difference in that, or L you can take, or so x is equals to wherever a is there, x also we can take. This is what? So x square, this is about dimension is x square, even this is x square. So the whole dimension is also x square. So therefore what we can write now, this one is x square or L square is nothing but L only, or x also we can say a power n. The whole thing is a number. Therefore what we get? X cancel, or a power n is equals to 1. That means what? Any to the power of, so this one is what? 0 is 1. That's why, so the value of n is 0 we can say. Right. Okay, so this type of questions are important. Need not to remember the this integration concept. Now let us come to, so this one, yes. Now, in this dimensionally, let us take what? Planck's constant h, speed of light in vacuum is c, and Newton's gravitation constant g are the three fundamental quantities. Which of the following combination of these has the dimensions of length is asking. Then how to do this type of things? So let us take what? Length. So depends on which one. So this is what? Planck's constant, and also c to the power of b or g to the power of c. We don't know. This length is depending on h, c and also g, but how it is depending on, we don't know. The powers we don't know. Dimensions we don't know. Then, so L we can write it as what? M0, L1, T0. Then Planck's constant is same as angular momentum. Okay, angular momentum and Planck's constant has same dimension formula, because mvr is equal to nh by 2 pi, or L is equals to nh by 2 pi. So that's why h and L have same dimension formula, that is equals to mvr is equal to nh by 2 pi. This and this is what? Same. M lt minus 1 into L, you can write like this: m L square t minus 1. M L square t minus 1 to the power of a. C is the velocity of light. That's why Lt minus 1 to the power of b. Then what is the dimension formula for g? Universal gravitational constant, m minus 1 L cube t minus 2. Of course, if you don't know, you can derive. So by using what? Distance square, or g is equal to fd square or fr square by m1 m2 m L t minus 2 into L square by m square. 1 m cancel, minus 1, m minus 1 L cube t minus 2. You can take like that. So m minus 1 L cube t minus 2 to the power of what we can write? C we can. Then, so we can write as what? M powers. If you take a minus c, must be equal to this power. This power is 0, and this is what? A, that is what? Minus c. So a minus c is equal to 0. That means a and c should have what? Same dimensional formula. A and c, that means what? H power, g power should have what? Same dimension formula. That's why by seeing this one, you can, once you check, this one is what? This options, if you check, h power 1 by 2, g power 1 by 2, c power minus 3 by 2. Now from this, so what about h power is a, this c power is, so b, and the g power is c we have. Okay, like this we have. But h and g have same dimension formula. This may be the correct. Then even this is what? H and which one should be same? H and G should have what? Same dimension. Yes, even here is also there is a so possibility. But here H and G should not have what? This is not having what? Same dimension formula, because H to the power of 1 by 2, G power we have 1 by, so this is what? If you take into numerator, minus 1 by 2 you get. This may not. So then what about this one? This is also not the correct answer. That means what? The answer is there. In these two, answer is there. Now Now let us take what another one, L powers. If I take L powers, if you take, so 2 power, so A and also plus B and also plus 3C must be equal to 1. So this A and C are same. That's why we can take it as what 2C. Wherever A is there, I'm writing what C plus B plus 3C should be equal to 1. 5C plus B is equal to 1 we can. Even so T powers also you can check. So what about the T powers? T powers is, then you can take it as, so C powers, then so minus A minus B minus 2C is equals to 0 we can. Now if I substitute A is equal to C, minus C minus B minus 2C is equal to 0, or B is equal to minus 3C we have. Then if I substitute 5C minus 3C is equal to 1, 2C is equal to 1, C is equal to 1 by 2. C is also, this is 1 by 2 we have. Okay, so now we can say it is what? C power. So this is what? 1 by 2. Is this right? Yes. 2A. Now we can take it as what here? C is, this is also, C is also having 1 by 2. So C is having 1 by 2 means what it is? 1 by 2 or 3 by 2? Let us see. Then, so let us take what A powers. If I take m1 L square T power minus 1, LT minus 1 and m minus 1 L cube T power minus 2. Yes. Then we can take it as what? A. So this is what? M power A and minus C is equal to 0, or A is equal to C. Then we can take it as what? 2A plus B and also plus 3 is equals to 1. Then A is equal to C means what? 2C plus B plus 3C is equal to 1. 5C plus B is equal to 1. Okay, that's right. Now let us take what? T power minus A minus B and also minus 2C. Yes, minus A minus B minus 2C is equal to 0, minus A is equal to C, minus C minus B minus 2C, or B is equals to what we can write? So minus 3C we get. Wherever B is equal to minus 3C, so if you can write, then this is what? 2C is equal to 1, or C is equals to what we can write? 1 by 2. Yes, of course. Then C is equal to 1 by 2, then is that right? A is equal to 1 by 2 or C is equal to 1 by 2, it's right. If you substitute here, minus 3 into C is what? 1 by 2, or B is equal to minus 3 by 2. B is minus 3 by 2 means what? Which one? Tell me. So this one is, B is what? B is nothing but C power is what? Minus 3 by 2. Therefore, what is the correct answer? So first option is correct. Okay, that way you can. Right. So you can take what equation, or sometimes they won't give this one is what? H power 1 by 2, G power 1 by 2. Some other they give. Then you can take, so even directly we can take there. Now, let us come to this one. This type of questions are very important in percentages. So now percentages if you take, so X is, what is the maximum percentage in X? Then X percentage is equals to what you have to do? Whatever the powers are there, you have to multiply. That means 2 into A percent plus 1 by 2 into B percent. Even they are in the denominator. Errors are, so will not be reduced. You have to add. That's why what we can take, 1 by 3 into C percent plus 3 into D percent. Whatever the powers are there, that you have to multiply. Even if you take into numerator, it is what? Minus, but don't take what? Minus, because errors cannot be reduced. Then, so 2 into, what is A percent? A is given as what? 1%, plus B is given as 2%, plus C is given as 3%, and also D is given as 4%. This cancel, then 2% plus 1% plus 1% plus 12%, which is equal to 14, 15, 16%. That should be the answer. Right. Next one, this is a maximum percentage we can take, so like this now, and also even, yes, another point we can take, let us take in this, yes, another point, let us take what by using, yes, we go to one question. Yes. So let us take this type of questions how to do. In an electrical circuit, the voltage is measured as 200 plus 4 and the current is measured as this one, the value of resistance. So what you have to do in this, R is equals to V by I we have. Then whenever if it is given, so to calculate percentage, what we can take, so this is what delta V by V into 100 plus delta I by I into 100, which gives what, delta R by R into 100. Just now I gave even, take into numerator, we have to take what, plus only we have to take this one, percentage of R. Then now delta V by V is, what is delta V? What is the change or error in that voltage is 4 by 200 into 100 plus delta I is 0.2 by 20 into 100. So which is equal to, this is what, 2 plus this is what you get here. This is what, 2, and also we can take it as what here. This is what, 0.1 we get. So then the value of resistance is asking. Okay. Then what about the value of resistance? Resistance means what? What we can take in this? This is about what? 2. Right. So let us take what, this is what, 4 delta V is equals to how much here? 4 by 200 into 100. That is what, 2 times. So 100 2s, that is what, 2. And also what about the current here? 0.2 by 20 into 100. So then what we get? This is what, 10 by, so this is what we get. Let us take what, 0.2 by 20 into 100, which should be equal to 20 by 20. So which should be equal to 1. Okay. So this is what, 1. 2 plus 1 is how much? 3 we get. So these about 3% we have. Then what about the R percent we have? Then this is R percentage is 3 we have. What is the R percent? Delta R by R into 100 is equal to 3 we have. So R we can take it as what this one is, delta R by R into this one we can take, or simply we can write what is in percentage. R is equal to V by I. But what is V? 200. But what is I? 20. So which should be equal to 10. So therefore what we can write, R. So in terms of percentage, what we can write, 10 plus or minus 3% we get. This is in terms of the percentage, because percentage of resistance is 3. This is 10 plus or minus 3%. But is asking in absolute error. For 100 it is 3. For 10 it is how much? 10 by 100 into 3 we have, then which should be equal to 0.3 ohm. Therefore, in terms of this one is what, absolute error we can take. So this is what in terms of the percentage, but in terms of the absolute, 10 plus or minus, this is what in percentage. In absolute we can write 0.3 we can write. This is what ohm. So you can take what, 2 things. Once again I repeat, look at here, R is equal to V by I. While taking what percentage, what you have to take? Delta V by V into 100, or 1 into V percent plus 1 into I percent, or delta I by I into 100. But what is delta V? What is the error in the voltage? 4 by 200 into 100. And what is the error here? 0.2 by 20 into 100. So which should be equal to 0.2 into 100 is 20 by 20 is 1. So whereas what this is 2 plus 1 is 3. This is in percentage, 10. So ohm, R is equal to V by I, 200 by 20. Actual value of the resistance is 10 plus or minus 3. But for 100 it is 3. Because 3% means what? For 100 it is 3. For 10 it is how much? That is 0.3. This is the, in terms of the absolute error. Either 10 plus or minus 0.3 we can write. Or if you want to write in percentage, I can take it as what? 10 plus or minus 3% also. Okay? Take. Right. Next one, similar to these percentages. Now, so I can take one thing. So let us see. One question we discuss based on this is what percentage even. So one important, let us see this question important. Let us take, so two resistors of resistances R1 100 plus or minus 3 ohms and R2 is 200 plus or minus 4 ohms are connected in series and in parallel. Find the equivalent resistance. Okay. So that is the question. Series and as well as for parallel. It's important. You must have to remember R1 is equals to 100 plus or minus 3. R2 is equals to 200 plus or minus 4 we have. So whenever they ask what resistance in series, series is nothing but R1 plus R2. So R1 sum of these restants. So sum means what you have to take, the original values of the restant should be added. 100 plus 200 is 300. Okay. So then these are the absolute error. In addition and subtraction, absolute error should be added. That's why what we can write, 3 plus 4 is how much? 7 we can take. So in either it is in addition or a subtraction. Even suppose if I am asking one resistance or one length is given or one breadth is given like this, then what about the difference of lengths? So let us take what this is L2 if it is given. So let us take here. So this one is what L2 is given, this is L1 is given, length is given this way meters, and second length is given, first length is given like this. What about the difference of lengths? Even the difference of lengths also what you have to take. So difference means what? 200 minus 100. The original value should be subtracted. 200 minus 100 is 100. Plus or minus, absolute error should not be subtracted even in subtraction. What you have to do? Should be added. Okay. But even addition also should be added, absolute errors. Even in subtraction also, absolute error should be added. Okay. That you have to remember. So then what about the restants in series? Simply we can take what? 200 plus 100 and absolute error should be added. But now once if it comes to what? Parallel. Okay. Once if it comes to parallel, what you have to take? Parallel means what? 1 by Rp is equal to 1 by R1 plus 1 by R2. So then one standard formula we get by differentiation. So 1 by Rp minus delta Rp by Rp square, because 1 by x differentiation is minus 1 by x square into delta x. Of course, just I'll give what one formula, minus 1 by R1 square minus 1 by R2 square into delta R2. Or simply we can take all delta Rp by Rp square is equal to delta R1 by R1 square plus delta R2 by R2 square. So this way you have to remember delta Rp. Now, then what about Rp if you take? What is delta R1? I write here delta R1. What about the error in the first resistance? That is 3. Okay, right. Then what about error in the second resistance? That is what? 4. Okay, then what is Rp? Rp is nothing but when they are connected in parallel, which is equal to R1 into R2 by R1 plus R2. That is equal to R1 into R2 means what? 4 into 3 by 4 plus 3, which should be equals to what we can write. So this one is what? Product by, one second. Then, so this is original resistance, that is, so R1 into R2 by R1 plus R2, which is equals to, so this is what? 100 into 200 by 300, 100 plus 200, which should be equals to 200 by 3 we have. Okay. So these about Rp we have this 200 by 3. Now we substitute in this, we can get, let us take what? Delta Rp, okay, is equals to what we have in this, delta R1 by R1 square plus delta R2 by R2 square into what we can write? Rp square we can. Then what about delta R1? Delta R1 is 3 by what is R1 square? 100 into 100 plus, then this delta R2 is 4 by 200 into 200 into Rp square. But what is the Rp we got? Rp is 200 by 3. That is 200 by 3 into 200 by 3. Then this 2 cancel, 2 to the 4, 1. Therefore, 3 by 100 into 100, 1 by 100 into 100, which should be equal to 4 by 100 into 100 into 200 by 3 into 200 by 3, which should be equal to 2 times, which should be equal to the 4 4 is the 16 by 9 we have. 9 ones are 9, 9 8s are approximate. Therefore, 1.8 we have, which is the delta Rp. Delta Rp. Then what we can write in parallel? Parallel it is product by sum plus or minus delta Rp we can. So which should be equal to what is the Rp? Rp is 200 by 3 plus or minus what we get? 1.8 we get. That's the way we can write in this in parallel. Right. Okay. Next. Now let us come to, so this one is C. In this, Now we come to, let us take even. The question asked in, in 2026 asked, 2026, each side of a metallic cube of mass, this one, measured to the 9 centimeters, keeping the significant figures in view. The density of the material of the cube can be best expressed. Density is equal to mass by volume. Okay, so this is equals to mass by, it is a cube. Cube means what we can write, mass by a cube. Then mass is equal to 5.580 by 9.0. So into, this is 9.0 into 9.0. Okay, this is the density. So now if you simplify this one, you get 7.654 into 10 to the power of 3 we have. Of course, as far as what significant figure, 10 to the power of 3, we won't consider. Then what about here? So in division and multiplication, whichever the minimum significant figures are there, total, that should be taken. What about the minimum here? So 2, 9.0 means what? It is 2 significant figures. Here is 1, 2, 3, 4. But minimum significant figures in total is 2. Therefore, we can take it as what? Of course, 10 to the power of 3. So we won't. Then this one is what? 7, 2 significant figure. But it is what? More than. So 50. Therefore, we can take it as what? 7.7 we can take. Because 6, so it is what? More than 54 means what it is? So 7 we take. Okay. 7.7 is the correct. This is 2026. Okay. So like this we can do the questions simply. Now let us take even. So this one we can take how to do. Let us check the time period of a simple pendulum is given as this one, measured value of the length. The pendulum 10 centimeters is known as to a 1 millimeter accuracy. 1 millimeter accuracy means what? It's the error. Then we can take length, we can take it as what? 10 centimeter plus or minus. So 1 mm accuracy. That means what? 0.1. Okay, centimeters we can take. And also then time period. So the time for 200 oscillations of the pendulum is found to be 100 seconds, and also plus or minus, this is what 1 second we have. Then what about the, so percentage of G is asking. Then T is equal to 2 pi root of L by G, or T square proportional to L by G, or G proportional to L by T square, then 1 into L percent plus 2 into T percent we can. So then L percent is equals to, we can write it as what? 0.1 by 10 into 100. So that is what? Error. Delta L by L into 100 plus 2 into, so delta T by T into 100. Then delta L is 0.1 by 10 into 100 plus 2 into, this is 1 by 100 into 100. So this is equal to 10 by 10 plus 2, that is equal to 3%. Therefore, so this one is the answer. Okay, the nearest integer of that is what? 3%, like that we can. Okay, so this is the way you can do the questions. So simple way, this chapter. Right, one last thing we discuss. So, and before we finish this session. Okay, yes. So even we can, let us take even that errors, even we have. And so another point we can take, so let us take what? Even the area of the rectangular field. We'll finish this one. Area of rectangular field, this one is length is given as 55.3 meters, and breadth is given as what? 25 meters. Then what about the value of correct significant digities? The area. Area is equal to length into breadth. When you multiply this one, 55.3 into 25, it gives what? 1382.5 you get. Then this is the area. But in multiplication, what you have to take? So this is the correct. How many total significant figures are there? 3. Here total significant figures are 2, but you have to get, so minimum significant figures, that is what 2, which should be equal to. So this one is what? So 2 significant figures should be there. But here is what 3 are there. Here is what 4. Here is 5 are there. Here is what 2. That, but the value should not be changed. 14 into 10 power 2, which is similar. This is what? Nearest to 1400. Or how many significant figures are there? 2. That's all. So this is the correct answer, 2 significant figures. Okay. So this way you can do this chapter easily, but definitely we get 2 questions. So from one is what units and dimensions, and also errors or significant figures you get. Okay. So so concentrate these chapters and easy to get marks. Okay. So all the best. We will discuss with another new chapter tomorrow.